Hello, my name is HanShe Lim, and I'm from James Cook University. I'm the lead investigator of a project which is looking at improving the resilience to flooding for a tropical catchment in Cairns. Well, the project looked at increasing the resilience to flooding in a tropical urban catchment in Cairns, and we use modeling as a tool to help us understand the role nature-based solutions play in reducing floods for different climate scenarios. Through this project, we got a better understanding of flooding in Cairns by looking at historical accounts through newspapers, old documents, and old maps. We also engaged with traditional owners to get their understanding and knowledge of waterway management and flooding. The best part about this project was reaching out and engaging with the traditional owners of Cairns to work towards better flood management. So this is a project about improving the flood resilience of an urban catchment in Cairns. And it's again done in collaboration with the Cairns Regional Council. So mainly to help them provide some help with them in terms of how they can manage floods. And in this project, we try to work quite closely with the traditional owners of Cairns. So that would be the Gimoy, Walubara, Yidinji people. So the next two slides show you a modeled, so it's not real, it's modeled extent of flood inundation for the northern part of Cairns for the 1% AEP event for 2020 and 2100. So this was done, this was a job that was commissioned by the council and run using two flows. So a lot of you are smiling just with the 1% AEP event for 2020, which is really past. The airport would have completely flooded, almost. And you can see that large parts of the Cairns city would be flooded to, well, probably 0.5 to more than 1 meter deep. So that's not ideal because we have our major road is a linear system that runs parallel to the coast. And going up the hills is possible, but there's only a few roads that go out and it would likely be jammed with traffic. So best way to get out of the floods is either boat or hike up the hills. So this is for 2020 and that's for 2100. So basically, you see a whole load of blue. And so the council has to do something about this to manage floods. But the problem with this area is all low-lying, as you can see. And most of the land is already used for development, so they don't have a lot of options. So the Arab council got Arab to kind of commission a study to look at nature-based solutions that can help maybe with reduce the impact of flooding. And they suggested that the best places to put nature-based solutions would be further upstream, where my mouse is pointing, in the upstream parts of this catchment. And so the purpose of this project is to do some flood modeling for catchment, this shown here, to see the impact of using nature-based solutions in a tropical urban catchment. For current climate scenario, for global, warming scenarios, RCP 4.5 and 8.5. And the models that we're using, unfortunately, is not two-flow. It's the MIPLA series of models. So this is our study site, which is Saltwater Creek, so up in Cairns in the tropical north. And that's our catchment there in northern part of Cairns. It's close to the airport. And the reason why we chose this catchment is because council has a lot of infrastructure in this site already. So there's quite a lot of flow and water quality data there. Whereas the CBD of Cairns, which is further south, slightly south, is where historical accounts have shown quite significant flooding have occurred consistently throughout the years. So flooding is due to high rainfall. That's no surprise. Storm surge, high tides, or I think we're supposed to get king tides soon, maybe this week or next week, I can't remember. And of course, cyclones. We haven't got any cyclones in the past few years, which probably make people a bit overconfident, but they do come and cause damage. So this is what some of the creeks in the catchment look like. well, typical. You find them similar things in Brisbane, concrete drains and somewhat semi-concrete drains. So some of the, in order for us to do modeling, first we need to understand what causes floods. And so we look into the past and we looked at historical material from reports and newspaper cuttings. And also we tried to engage with traditional owners to see if they had any information about past floods that they could share with us. So that's first step, is to understand flooding, the nature of flooding in Cairns. And then the next step was to use modeling as a tool to try and see what extent of flooding would occur, and the impacts of nature-based solutions in mitigating this flooding. It may fail, it may not. We don't know. So that's what the model is there for, to test like virtual experiments again. And then, of course, the other component is to engage and talk to the local stakeholders, so traditional owners and non-traditional owners. So any interested person, they're all welcome to engage with us. So on the right, there is a picture of flooding, not flooding, heavy rainfall due to a cyclone in 1878. So what we did was these are our methods. We look at historical information. We tried to get Indigenous knowledge, and we did some modeling, and engagement is an important component. But I must also say that this project is not complete yet. It's still ongoing, so I don't have a lot of results to show you. And I also realized through this project is that you guys are doing so much more advanced work with the traditional owners than we are. We are just starting to work with them. So there's a lot of things that we can learn from all of you. So first thing, we employed historians to go through all the historical information. And basically what we were after was to find out the location and depth of flooding, when flooding occurred, how flooding occurred, was it a fast response to rainfall, and also proposed solutions. So proposed solutions, not a new thing. Over 100 years ago, there were engineers who said that they need to enlarge the size of the pipes. And so we can see that here we also looked at changes in the landscape. And one of the most important things is, the black line shows the boundary of this saltwater creek catchment that we're looking at. But in the past, what we can see is that there were a lot of swamps in Cairns. It's a swampy area. You have both freshwater swamps shown in beige and saltwater swamps. And a lot of them were filled in to deal with floods. So what you can see is this is within the catchment itself. This is the remaining part, swampland in the catchment, shown in green, and blue as the water bodies. So we've lost a lot of swampland, which in the past would potentially hold some water. And then we also looked at the accounts. So when we read through the accounts, newspaper accounts and so on, you have people telling you, oh, the flood came up to their knees and so on and so forth. And we kind of knew where they were located. So this map is a bit hard to see, but we basically just mapped the places where we know flooded and the flood depths. And you can see that if you can't see the coloring, it's okay, fine, no problem. What we actually found is that there were not a lot of accounts of flooding in our catchment that we were studying, but there were lots of accounts of flooding in Cairns City, which is further south. So we had to extend our study. So of course, proposed solutions would be drains, but also we found that this is all the swampland, and this is also swampland at the bottom that got filled. So drains were the typical solutions to the flood problem, which is of course no surprise. But then you also see accounts where they said very clearly that the engineers made mistakes. So just something to think about. So some of the proposed solutions that we found: fill the swamps, you raise the roads, build new seawall, higher seawall, increase the size of the drainage pipes. So no surprise, I'm sure that you use the same solutions in Brisbane and elsewhere, back all over the world. But if you look at this quote by an engineer in 1940, it shows that there is also acknowledgement that these proposed solutions may not actually work when it rains very heavily, because it says impossible to keep Lake Street free from storm water. So we do have to acknowledge that sometimes the floods are there and we have to live with them. And a lot of this work actually is inspired by Margaret Cook's book, The River with the City Problem. So a similar kind of approach, try to get as much information as we can to make better plans to deal with floods. So even in 1943, there were proposed drainage works. So these are shown by the green. And of course, again, there's lots of accounts in the newspapers which talk about proposed solutions, whether they work or not, and people's views towards these proposed solutions. And we can see from mapping is that the drainage extent actually has expanded over the years. We can see 1949, the blue lines are just, it's very sensitive mouse pad. Blue is the drainage network in 1949, and by 2020, you got much more lines shown in purple. So yeah, that would be drains are favorite of the flood mitigation strategy, but clearly it doesn't work. So we want to explore the role of blue-green infrastructure, but because we don't have a lot of land, we have to be quite creative about the types of blue-green infrastructure that we can implement in the catchment. So as part of the project, we also ran one community meeting with traditional owners to find out their views about flooding, creeks, and a lot of other environmental issues. So this is really the start of the conversation with them. We haven't got any concrete solutions that they would like, but we just make friends with them first. And then we also ran we worked together with the traditional owners. So picture on the right here, so walking the creeks, and we had the rangers, students, and various scientists just walking the creeks and saying, oh, maybe this land here, we could make it a park or a detention basin, and that sort of thing, just engaging in conversation with them. And then, of course, we also, as I said, modeling. We used Mike Plus, and we were interested to model a different scenario. So the current gray infrastructure of drains, then we wanted to put in some nature-based solutions as a different scenario, and do this modeling for 3 different climate scenarios: current scenario, RCP 4.5 and 8.5. This work is undergoing because it's a bit delayed, but this is our plan, and we will deliver something to Jenny by December. So until then, I don't have results to show you. So just if you're interested, just contact me separately. So key points: Cairns is a city of extremes. We got lots of heavy rainfall, but also historical accounts tell us that it can have years of drought. So it's highly variable. And to actually manage floods, we need whole types of different information and different stakeholders involved working together to deal with the flooding problem, because we don't have a lot of solutions. We've got very little land before the mountains. So we really have to be quite innovative. So that's the importance of collaboration. That's it. Thank you. Any questions?
So we all need to come back in December and listen to
no, I don't think you want to do that.
Excellent. So again, has anyone got any questions for HanShe about flood resilience games? Question up the back. If you introduce yourself first of all.
If you could talk a bit more about what kind of blue or green solution you are investigating.
Yeah. So in the saltwater creek catchment, there are some detention basins already, but as I said, because land is limited, so we wanted to do very simple things like one rainwater tank. It's not really blue-green rainwater tank. And then green roofs is another option. And then small rain gardens where we can fit them wherever there is space in car parks. The other thing is also in Cairns, there are a lot of parks that are just grass. So council spends a lot of money mowing the grass, and it's an empty space, People don't go there at night because it's dangerous. And so those areas could potentially be developed into maybe recreational multi-use areas, which form part of the blue-green infrastructure of the site. But they have to be further upstream, because downstream where you saw all the blue, it's basically, there's not much land to do anything, and it's going to flood badly anyway, especially if you have king tide and storm surges. It's not a good situation. Don't ask me about relocation, because I don't have an answer to that.
Before you answer Elaine's question, Could you just briefly paraphrase it back so
Yes,
that people
yes,
online can hear?
definitely.
I think it's the microphones don't pick up the
Okay,
audience. So well.
so the question that
Oh,
Melanie.
no, for Elaine.
Oh,
the next
sorry,
one.
Elaine, yes.
When I was last in Cairns for a conference, there was a very great talk about how the traditional owners used to cultivate the little sand ridges to protect that area from cyclones. And I think there was a lot of cultivation of natural features to actually the areas that they wanted to. But so
Yeah.
I guess my question is two parts. One is, have you looked at that sort of land management? And the second part is, have you looked at permeable pavement and other changes to existing infrastructure?
Yes, okay, I cannot answer for the council because I don't work for them, but the sand ridges, so there are a lot of roads that are parallel to each other in the city, and those are actually, I heard, built on the sand ridges. We can't really move the roads. The sand ridges, a lot of them have been kind of, they don't really exist anymore, and you can find remnants of them here and there. I might be wrong, Jackie. We have to check with John. Yeah, but permeable pavements is definitely a very workable option because we use a lot of that in Singapore, and I was actually quite surprised that we don't find them here in Cairns. So that is also another option that we will test with the modeling. So yeah, permeable pavements may work, but then we also have to worry about the groundwater table, which can be quite high in the coastal area. So we have to be quite creative. So does that answer your question?
So you just don't know about that.
The sand ridges, yeah, I think the morphology is still more or less there. Jackie, do you have any comments about that? Yeah.
Was any gaps?
Glenys might have a comment about the sand ridges, yeah, but
so the sand ridges are still the sand ridges are still visible in the landscape as slight inundations from their cyclone deposits over the years, but a lot of them, they're so developed over that you really don't see them.
Okay, can you introduce yourself, mysterious voice online?
Serious voice online. There you go.
that's Glenys.
Principal scientist living in Cairns, backing on to Les Davies drainage park. So, it's very relevant to me, this study.
Right, Glenys. We've got another question from Paul.
One coming in Europe with the living pole homes rather than the slab on the elevated
How?
pole.
Yeah, the float, yes.
If any, there is one in the council subdivision for the youth club. Moving towards through the flow underneath the houses instead of houses, creating dams in the landscape.
Not that I've heard of, but the engineer that I was working with in council, he has quit his job, so I don't know what is yeah. But the other option is just have a bowl. Yeah, because those big infrastructural changes required, and I don't know if it's ideal, but yeah. We can float it around with the stakeholders for a start, but I don't think council is thinking of that yet. They're still in a very drainage mode. And to get them to even think about nature-based solutions is really like a sudden big win. Yeah.
Last question, Tony.
That really see, because you're really stuck between the mountains and the flats, and getting this, later it's really difficult. I think the challenge with nature-based solutions is we need room, and so I think the vision is where you I'd love to use multi, but every time we go into there, the park people say, "Oh, you can't flood them." This is a plan.
Yeah. We might find that we need both
Yeah.
the drains and the nature-based solutions may fail. And if they fail, we have to accept that, but at least we tried.
So look, thank you, HanShe.
Thank you.